This is Lisa. In this video, we'll be talking about special products. One of the special products that we're going to talk about comes from multiplying conjugate pairs. When we have a conjugate pair, the first thing in each parenthesis is the same, and the last thing in each parenthesis is the same, but the signs are different. One parenthesis we're adding, and in the other we're subtracting. When we multiply conjugate pairs, x times x is x squared. X times minus y is minus xy. Y times x is plus xy. And y times minus y is minus y squared. If we combine those middle two terms, notice what happens. They add up to 0, so they leave us with x squared minus y squared. This is called a difference, because we're subtracting, of two squares. Two squares, we have x squared and y squared. So if we can recognize that particular pattern, it makes factoring quite easy. If we have the difference of two squares, such as, say we have 4 squared minus, what's another square? 9 squared. Those are two squares. The first thing being squared is 4, and the last thing being squared is 9. We can write the factors as the sum of what's being squared times the difference of what's being squared. So first plus last times first minus last. Let's do an example. We have x squared minus 16. Can I write this as something squared minus something squared? And the answer here is yes. X times x, or x squared, gives me x squared. 16 is 4 squared. So my pattern, it's the first plus the last, and the first minus the last. I have a plus in one parenthesis and a minus in the other. The first thing in parentheses is x, and the last thing in parentheses is 4. And now our polynomial is factored. If I check by multiplying, x plus 4 times x minus 4. X times x is x squared. X times minus 4 is minus 4x. 4 times x plus 4x. And 4 times negative 4 is negative 16. And our middle terms do indeed cancel each other out. X squared minus 16, that checks. That was the original binomial that we were factoring. Example 2, we're going to use the same method. Can I write this as something squared minus something squared? 81x squared. 81 is a perfect square. 9 squared gives me 81. X squared gives me x squared. What's the square that gives me 25? Or in other words, what's the square root of 25? That would be 5. So again, we're going to do this first plus last, first minus last. The first thing in parentheses, when I look up here, the first thing in parentheses is 9x. That goes in the first spot in each of my two parentheses. The last thing being squared is 5. That goes in the last spot in each of my parentheses. And I've just factored my binomial. Let's do a couple more examples. Can I write 49x squared as something squared? Minus, can I write 9y squared as something squared? You multiply 7x times 7x, you will get 49x squared. And if you multiply 3y times 3y, you will get 9y squared. So again, we're going to do our parentheses. Doesn't matter if I do a minus in one and a plus in the other. The order of those is not important. What's important, though, is that the first thing that we're squaring is 7x. So that goes in the first spot of each parenthesis. And the last thing we're squaring is 3y. That goes in the last spot in each parenthesis. We're going to do the same thing. 100m to the fourth minus 36 n to the 4th. 100 is 10 squared. And m squared squared, remember, power to a power, we multiply, so m squared squared gives me m to the 4th. 36 is a perfect square. 6 squared is 36. And n squared squared is n to the 4th. So I do have a difference of 2 squares. The first one is 10m squared. So when I do my plus and minus in my parentheses, I do 10m squared first. And last, we have 6n squared. And again, you can multiply that out to check and make sure that you have the correct product. Now we've been talking about a difference of 2 squares. If we have a sum of 2 squares, it is prime unless there is a common factor between the 2 squares. So this is x squared plus 5 squared. But think about the possible ways that we could factor it. X plus 5 times x plus 5. But when I multiply out, the outside gives me 5x and the inside gives me plus 5x, I get a 10x as my middle term. If I do x minus 5 times x minus 5, again, here I'm going to get minus 5x and minus 5x. I'll get a minus 10x as my middle term. And if I do x minus 5 times x plus 5, that would work, except my very last term, negative 5 times positive 5 is negative 25. So none of those possible ways works. We know that this is always going to be prime. A sum of squares is always prime unless there is a common factor. So in example 2, if we look first for, do we have common factors here? The answer is yes. I can factor out a 4 because 16 is 4 times 4. And I'll have x squared plus, I factor out one of those 4's, I have 4y squared left. Now I have a sum of 2 squares. That's as far as I can factor. All I can do is take out that greatest common factor for that polynomial. Now I do want to make a note that a sum of cubes and a difference of cubes can be factored, but we will not address those in this course. So x cubed plus y cubed can be factored, and x cubed minus y cubed can also be factored. When we're talking about those odd powers, both the sum and the difference can be factored. We're going to talk about multiplying square binomials as well. Remember, when you have something inside parentheses and you're squaring it, you have to write it down twice if you have a plus or a minus in your parentheses. And if we multiply this out, we will get x squared plus xy plus xy plus y squared. Combining the middle terms, we get x squared plus 2xy plus y squared. And similarly, when we do x minus y times x minus y, we will get x squared minus 2xy plus y squared. The result of multiplying a square binomial is called a perfect square trinomial. So we're going to talk about factoring a perfect square trinomial. Now, you don't have to use this method. You can just look at it as it's a trinomial. I know how to factor trinomials by grouping. I'm going to do it that way. If you can identify, though, perfect square trinomials, there's another method to use. So first, to determine whether you may have a perfect square trinomial, if the sign of the last term is positive, the polynomial may be a PST. Notice in both of these, the last term is positive. If the first and last terms are perfect squares, so first term is x squared, last term is y squared. first term is a perfect square, last term is a perfect square. It may be a perfect square trinomial. You may have a perfect square trinomial. Try to factor the first and last terms. Then determine whether to add or subtract the first terms. So if we take that first example, we had x and x, y and y. In the first example, everything was positive. Our middle term was positive. Those are both positive. In the second example, the middle term was negative. We would make both of those negative. Then see if this is the correct product by multiplying the inside and the outside terms. The sum of these products should yield the middle term in the trinomial. And the last step is to write the product as a perfect square binomial. First plus last, quantity squared, or first minus last, quantity squared. So let's look at an example. Number 1. So we're going to look, is the last term positive? Yes. Is this a perfect square? And is the last term a perfect square? And the answer is yes. This one's x, and this one is 5 squared. So we're going to try and break it down. And the method that was there said do first, last, first, last. The first one is x, the last one is 5. My middle coefficient is positive, so I'm going to do plus here and plus here. Multiply the inside and the outside terms. I get 5x plus 5x is 10x. That is my middle term. It means this factors x plus 5 squared. There's our perfect square binomial. Number 2, we're going to try that method again. Is the last term positive? Yes. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. Then we can write it as first and last, first and last. The middle term is negative, so we're going to use negatives in our parentheses. And to check it, we're going to multiply the inside and the outside. Negative 3 times x is negative 3x. X times negative 3 is negative 3x. And when I add them together, I get negative 6x. That is my middle term. So it tells me that it factors x minus 3 squared. I do have a perfect square trinomial. And I factored it as a square binomial. Another example. Is my last term positive? No. So we know that this is not a perfect square trinomial. That right there says it's not going to factor the way that we have been factoring. So you can try to factor this as a trinomial. In an effort to save some time here, I'm going to tell you this polynomial is not factorable. This one is prime. Not all of them are prime that are not perfect square trinomials. This one happens to be. Example 4. Do we have a positive last term? Yes. Is the first term a perfect square? Yes. 6x squared gives me 36x squared. Is the last term a perfect square? Yes. If you square 7y, you will get 49y squared. So remember, we're going to do first and last, first and last. The middle coefficient is negative, so we're going to use subtraction signs in both of our terms. Negative 7y times 6x is negative 42xy. 6x times negative 7y is negative 42xy. And if I add those together, I get negative 84xy. Does it match my middle term? Yes. Then we know that this polynomial factors as 6x minus 7y quantity squared. All right, last example for this video. Do we have a positive last term? Yes. Can I write the first term as something squared? And the answer is no. 10 is not a perfect square. So this one is not a perfect square trinomial. Can I try to factor it? Yes. The first thing I'm going to do is take out a greatest common factor of 10. That leaves me with x squared minus 5xy plus 10y squared. I can at least factor out that greatest common factor. Now, if I want to see if this will factor, I look at all the possible ways to factor a positive 10. 1 times 10, negative 1 times negative 10, 2 times 5, or negative 2 times negative 5. Do any of those add up to my middle coefficient of 5? The answer is no. None of them will add up to that middle coefficient of negative 5. I know I can't factor that trinomial. The only thing I can do here is take out the greatest common factor of 10. This is completely factored. And that concludes video 13.4. Please complete the homework and the quiz. Have a good day.